So today we are going to discuss a subject, that is linear algebra. The topic is matrices. Now we are going to find the eigenvalues and the eigenvectors. The eigenvector V is an eigenvector of matrix A, and lambda is an eigenvalue of A. If A V is equal to lambda V. Now here A is the square matrix and V is the column matrix, and lambda is unknown quantity we are going to calculate during some algebraic the computations. Now how to find this eigenvalue and eigenvector? So for such we have to find the characteristic equation. How to find the characteristic polynomial? So we find by using the following equation: determinant of A minus lambda I is equal to 0. Now here lambda is eigenvalue and I is the identity matrix. So the order of this identity matrix is matched with the order of the matrix A. Now let us see some example we take and try to find out the eigenvalues and eigenvectors. So capital A is equal to 5 minus 2, 6 minus 2. We find the characteristic equation by using above, that is a definition. So from that we get lambda square minus 3 lambda plus 2 is equal to 0. So solving this equation we find the eigenvalues. Let us call lambda 1 is equal to 1 and lambda 2 is equal to 2. Now by using these eigenvalues and from the equation A V is equal to lambda V, we find the eigenvectors. Now let us see the important and interesting properties of the eigenvalues and eigenvectors. Now let us see the number 1. Eigenvalues and eigenvectors are only defined for square matrices. That is, the order of row is equal to order of column. So next thing, eigenvectors are not unique. Example, if V is an eigenvector of the equation AV is equal to lambda V, so K times V again an eigenvector. So from this we can understand that for a given eigenvalue the eigenvectors are not unique. Next one, suppose lambda 1, lambda 2, lambda n are the eigenvalues of capital A, then we find the trace of the matrix A. So that is obtained from the summation of the eigenvalues. Next, we can also find out the determinant of A, so by multiplying all the eigenvalues of the matrix A. Now in case if one of the eigenvalue is 0, then the matrix is not invertible. Now next thing is capital A and capital A square have same eigenvectors. It is also true for A power n also. Now Another property is if lambda is an eigenvalue of A, then lambda square is an eigenvalue of A square. Similarly, lambda power n is an eigenvalue of capital A power n. Next, a matrix A with positive eigenvalues is called positive definite. In such case, we'll get the following property that X transpose capital A and X is greater than 0 is true for all X not equal to 0. Here capital X is the eigenvector. Now, let us now discuss about the diagonalization, which is one of the important property if we know the eigenvalues. Now, given matrix A, find the model matrix P such that P inverse A, P is diagonal. That is, P diagonalizes capital A. Now, next point is, let us take that P as the collection of all the eigenvectors of the matrix A, where V1, V2, and Vn are the eigenvectors of the capital A. So, in such case, we find the diagonalization of the matrix A by using the eigenvectors. That is, P inverse AP is given by the diagonal elements as the eigenvalues, and rest of the elements of the matrix are 0. Now, let us we try to take the example. Consider A is equal to 2 by 2 matrix 1, 1, 1, 1. The eigenvalues are 0 and 2, and corresponding eigenvectors are 1, minus 1, let us call it as V1, and V2 as 1 and 1. Now here the P is taken as 1, 1, minus 1, 1, and its inverse, that is P inverse is equal to 1 by 2, minus 1 by 2, and 1 by 2, 1 by 2. Now diagonalization is given by P inverse A P is equal to 0, 0, and 0, 2. Now here we can see the diagonal elements are 0 and 2, which are the nothing but the eigenvalues of the matrix capital A, that is 1, 1, and 1, 1. Now, let us say that are all n-cross n matrices diagonalizable? That is one of the interesting question. If you want to get the diagonalization, for such, it is very important, P inverse exists. So now next point is, if capital A has n distinct eigenvalues, let us call lambda 1, lambda 2, dot dot lambda n, then the corresponding eigenvectors v1, v2, and vn form a basis. That is, the eigenvectors are linearly independent and span R power n. Now, diagonalization, which is implies that decomposition. Let us discuss about it. Let us assume that capital A is diagonalizable. In such case, we can write P inverse A P, and it is written as the eigenvalues as the diagonal elements and rest of the elements as 0. So from that we can write what is capital A. So that is P times of the diagonal matrix, that is lambda 1 are the diagonal elements and rest of the elements are 0, and multiplied by right side P inverse. Now I stop here the discussion about the eigenvalues, eigenvectors, and diagonalization, decomposition, etc. Now I keep this topic for the discussions.